All right, this is dividing polynomials practice, and as always, I am the amazing Mr. Jansen. So away we go. If I look at the first one, I've got a polynomial divided by a monomial. And when I'm doing this, these are the easy ones. I just have to use my distributive property. Okay, so what I'm doing here is my distributive property, so I'm distributing the division to each of these terms. Okay, in other words, I'm going to take the first term, which is the 15r squared, and divide it by the 5r to the fourth. And then I'm going to take the next term and divide it by the 5r to the fourth. Then I'm going to take the last term and divide it by the 5r to the fourth. Okay, and now I just have to simplify each of these. I divide the coefficients, subtract the exponents. So for this first one, that's going to be a 3r to the negative second, minus, this is going to be a 1, which I don't need to write, r to the fourth. And then this one is going to be a plus 8, again, r to the negative second. Now if I look, I have like terms here, same variable with the same exponent, so I combine like terms, which is going to give me an 11r to the negative second minus r to the fourth. And of course, you can rewrite this so that we have positive exponents. So this would be 11 over r to the second minus r to the fourth. Okay, and that's it. If I look at the next one, I'm doing the same thing. I'm dividing each term by the monomial. So when I do that, I'm going to write out this intermediate step. You don't have to write out this intermediate step, but it helps to keep things organized and helps us not make silly little mistakes here and there, especially with this last term. So again, I divide the coefficients, subtract the exponents. So it's going to be a k to the first, and I don't have to write the 1. Here it's going to be, that's m to the first, so that's going to be an m to the negative first. Minus, this is going to be a 6 k squared. Here I subtract the exponents, that's going to give me an m to the 0. Anything to the 0 power is 1. I don't need to put a 1 in there. Plus, here that's going to be 9 halves. Here, if I look at this, the k value doesn't have anything to subtract from. Remember, there is a k to the 0 right here. I can put k to the 0s anywhere I want because that's the same thing as saying times 1, which doesn't change anything. So now if I subtract the exponents, this is a k to the first, that's going to be a k to the negative 1, and then this is going to be an m to the first. Now I can take care of the negative exponents. That's going to be a 3k over m minus 6k squared. And this is going to be a plus 9m over 2k. And that's it. All right, this is where the fun begins, of course. If we look at each of these, I'm dividing. This time I have a polynomial divided by a polynomial. So there's two options here, either long division or synthetic division. And we can only use synthetic division if it's possible to use synthetic division. It doesn't work all the time. If I look at this first one I have to use long division for because I've got a 2 in front of the x value. All right. Remember, for synthetic division, it has to be a first-degree binomial with a leading coefficient of 1, and this one doesn't have it. All right, so I'm going to set up long division. So I've got the 2x minus 3 out here. Underneath, I've got the 4x squared minus 2x plus 6. I have to put zeros in for any missing terms, which I don't have any here. So now I compare the first terms, the 2x and the 4x squared, and I ask myself, what do I have to multiply the 2x by to get a 4x squared? And the answer to that is I need a 2x. Okay, so now I multiply. I take the 2x times what's out front, and I have to distribute. Okay, so again, that's going to give me a 4x squared minus 6x. And now I have to subtract. Remember, this is a big subtraction sign. I'm subtracting this whole thing. So I'm going to change it to adding the opposite. That's the same as adding the opposite. And I have to change each sign that's there. So now I'm adding instead. So that's going to give me a 0 and then a 4x. The plus 6 tags along for the ride. And now I look at these two. And I say, okay, what do I have to multiply by in order to get the 4x? Positive 2. So now again, I distribute. 2 times the 2x is a 4x. 2 times the minus 3 is a minus 6. I'm subtracting this whole thing, which is the same as adding the opposite. So that's going to be a 0 and then a 12. All right? There's nothing I can multiply the 2x by in order to give me a 12, so that's my remainder. So I put a plus 12 over the thing I was dividing by, which is the 2x minus 3. And I'm done. Okay? So the answer was 2x plus 2. I'm going to rewrite it down here, plus 12 over 2x minus 3. Okay? For the next one, I notice here that I have a negative exponent. Remember, a negative exponent means I have to send whatever that is to the denominator. So that means I'm going to take this whole thing and I'm going to send it to the denominator. So I'm going to put the the y plus 2 underneath. Okay? And that's all that negative exponent was doing. It's just a fancy way of writing division. So now I've got 6y to the 4th plus 15y to the 3rd minus 28y minus 6 divided by the y plus 2. And for this one, I can use synthetic division because I've got a binomial here with a leading coefficient of 1, and it's of the first degree. Here's where I can use synthetic division. Okay? So I take a look at this. It's a plus 2. I take the opposite of that, which would be a negative 2, and I put it in my box. Now I write down the coefficients of what I have up here, and I have to put zeros in for any missing terms. So I've got 6, 15, and then here's where my 0 goes, because if I look, I was missing a term. I've got a y to the 4th, y to the 3rd. I'm missing a y to the 2nd, so I have to put a 0 in its place. Then I have the y value. I need each term in descending order. So now I've got a negative 28 and then a negative 6. I put down my addition bar, okay, because I'm going to be adding these things. I bring down the first coefficient, which is the 6. And now I multiply. Negative 2 times 6 is a negative 12. And now I add straight down, which is going to give me a positive 3. And now I multiply. Negative 2 times 3 is a negative 6. I add straight down, which gives me a negative 6. Then I multiply. Negative 2 times negative 6, which is a positive 12. And then I add straight down, which is going to give me a negative 16. And then I multiply. Negative 2 times negative 16 is a positive 32. And then I add straight down. And when I add those, it's going to give me a positive, that was a close one, a positive 26. All right? Since the thing I was dividing started with a y to the 4th term, my answer is going to start, so it's going to be one less, y to the 3rd. So that's 6y to the 3rd plus 3y squared minus 6y minus 16 plus, this is my remainder, so I put it over the y plus 2. Okay? And there's my answer. Easy enough? If I look at this next fella, the thing I'm dividing by is the x plus 3. Since that is a binomial of the first degree with a leading coefficient of 1, I can use synthetic division. So I take the opposite of this guy and put it in my box. So since that's a plus 3, I put a negative 3 in my box. And now I write down the coefficients. I've got an x to the 3rd, so that's a 2. I'm missing the x squared value, so I have to put a 0 in its place. Let me give myself a little more space here. Then I have the 4, and then the negative 6. I bring down the first coefficient, which is the 2. Now I multiply. Negative 3 times 2 is a negative 6. I add straight down. And then I multiply. Negative 3 times a negative 6 is a positive 18. I add straight down, which is 22. And now I multiply. Negative 3 times a 22 is going to give me a negative 66. And now I add straight down, and negative 6 plus a negative 66 is a negative 72. Since my original problem started with an x to the 3rd, my answer is going to start, so it's one less, with an x squared. So that's 2x squared minus 6x plus 22. And then this is my remainder, and I can call it minus, or I could say plus a negative 72 over x plus 3. And that's it.